Hello to all. My name is Vivian Kishore. Today we are going to discuss about Newton's method and its application of optimizing the impedance of an RLC circuit. The contents we are going to discuss today are introduction to Newton's method, introduction to impedance, problems of having high impedance, why optimizing the impedance, benefits of having lower impedance, how to approach the problem, algorithm, detailed explanation of the code using an example, result of the example code, why the Newton method is preferred or other methods, benefits of impedance optimization and its applications. Let's start with introduction to Newton's method. Newton's method is an iterative numerical algorithm for finding the roots of a function. The basic idea of Newton's method is to make an initial guess for the root of the function, and then improve the guess using the slope of the function at the current guess. The method starts by choosing the initial guess x0, then iteratively improves the guess using the formula x1 equals to x0 minus f of x0 by f dash of x0, where f of x is the function whose root we are trying to find and f dash of x is its derivative. The value x1 is the new guess for the root. This process is repeated with the new guess x1 and so on until a sufficiently accurate estimate of the root is obtained. This is the generalized graph of Newton's method. Next, we'll see the applications of Newton's method. Some of the basic applications of Newton's method are it is used for finding the roots of the equations. It's also used for optimizing the given function or an equation. It's also used for solving many differential equations. Mainly, it is used in image processing and machine learning. In image processing, Newton's method is used for image restoration and image registration. In machine learning, Newton's method is used to optimize the parameters of a model. This method, this model is particularly a logistic regression where the goal is to find the parameters that maximize the likelihood of the data. Now, this is a general example of how to use Newton's method for finding the roots of a function. The function we have taken is x power 7 minus 1000. Here we have taken 6 iterations. That means we have done Newton's method for 6 times now to find the roots. Now this is the algorithm for using Newton's method for finding the optimized values or optimized values of a function. The basic algorithm is start with an initial guess x0 for finding the minimum and maximum of the function. Next, compute the derivative of the function at the initial guess. Next, compute the second derivative of the function at the initial guess. Then calculate the next approximation x1 using the formula x1 equals to x0 minus f dash of x0 by f double dash of x0. Repeat the steps until we get the new approximation x1 until the difference between successive approximations is smaller than a specified tolerance. If second derivative at the final approximation is positive, then x is the minimum of the function. The second derivative is negative, then x is the maximum of the function. Next, let's get into impedance. Impedance is a measure of opposition of an electrical current to flow of the circuit or flow of the current, sorry, and it is a complex quantity that includes both resistance and reactance. In an RLC circuit which consists of resistor, an inductor, and a capacitor connected in a series or parallel, the impedance Z of circuit can be calculated using the formula Z equals to R plus J XL minus XC, where XL is the inductive reactance and XC is the inductive capacitance. For some circuits may have higher impedance. There are some problems for having higher impedance. The problems of having high impedance are signal attenuation. High impedance can cause the circuit to attenuate or weaken the signal being transmitted through the circuit. Signal distortion. High impedance can cause signal distortion due to reflections and standing waves in the circuit. Power loss. High impedance can cause power loss due to voltage drop across circuit. Limited frequency response. High impedance can limit the frequency response of the circuit, making it less responsive to changes in input signal. Why optimizing the impedance? As you can see in the previous slide, we have discussed the problems of having higher impedance. So that's why we optimize the impedance to get a lower values of impedance. The benefits of having lower impedance. The lowering the impedance of an RLC circuit can offer several benefits, including improved power transfer efficiency. Lowering the impedance of an RLC circuit can improve the efficiency of power transfer between the source and the load. Reduce signal distortion. Lowering the impedance of an RLC circuit can reduce the signal distortion caused by interaction between the circuit and the load. This because of lower circuit impedance can provide a better match with the load impedance, which results in less signal reflection, less distortion. Improved frequency response. Lowering the impedance of an RLC circuit can improve the frequency response of the circuit, making it more responsive to the changes in the input signal. Increased bandwidth. Lowering the impedance of an RC circuit can increase its bandwidth, which is the range of frequencies over which the circuit can operate effectively. Now, this is the way how to approach the problem. By the problem, I mean how to optimize higher impedance. Defining the problem, identify the goals of the optimization problem, which in the case is to minimize the impedance of an RLC circuit. Next, formulating the problem. Formulate the problem as a mathematical function of the expression that impedes that of the impedance of the circuit as a function of circuit parameters RLC. I mean resistor, inductor, and capacitor. Then the frequency of input signal. Solving the problem. Use Newton's method to find the minimum impedance of the circuit by iteratively updating the circuit parameters until convergence is achieved. Evaluate the results. Verify the results obtained by comparing them with the expected values, analyzing the sensitivity of the results to change in the input parameters, evaluating the trade-offs between performance and other design considerations. Next, implementing the solution. Implement the optimized circuit by setting the circuit parameters to the values obtained in optimization process and test the circuit to verify its performance. Next, this is the algorithm of how to implement Newton's method for optimizing the higher impedances in C++. First, define the RLC circuit. You can start by defining the RLC circuit in C++ using standard equations of impedance of an RLC circuit. Next, calculate the impedance. Using the defined RLC circuit, we can calculate the impedance of the input frequency using standard impedance equation. Next, calculate the derivative of the impedance. We calculate the derivative of the impedance with respect to the values of the components using standard derivative formula. Next, initialize the component values. We initialize the values of components to some initial guess. This guess can be arbitrary, but it should be close to the actual values of the components that produce the desired impedance. Update the component values. Using the gradient of the impedance, we update the values of the components using Newton's method. Check for convergence. We check whether the updated values of the components produce a new impedance that is closer to desired impedance. Repeat the process. We repeat the above steps until desired impedance is achieved or until the algorithm converges to a solution. This is an example. This is the complete code of what we discussed above. Now let's see the this is the output if this is the output we'll get if when we run the code which is shown before. Now let's see the detailed code explanation. At first, we'll define the basic impedance of the RLC circuit. At first, we'll write a code which will define the basic impedance of an RLC circuit. I mean, in C++, we'll write the equation of an impedance. Next, we'll write a code where we define the first and second derivatives of the impedance with respect to omega. By omega, we mean frequency. Next, we'll write a code which will define initial values. By initial values, I mean the basic frequency, the basic error rate, the number of max iterations, the initial iteration. Next, we'll create a while loop for controlling the iterations. Next, we create a if loop for controlling the iteration difference that is less than the limit. Next, we write a code for updating the frequency values after the iterations. Next, we write a code to inform when the operation reaches max iteration limit. Then we write the main function. This is the main function. In main function, we initialize the values of RLC. The basic R value we have taken is resistance 10 ohms. The basic L value is 1. The basic C value is 1 e-6. The result after running the example code. This is the result we will get after running the code in any online compiler or offline compiler. Initial impedance for the initial values of RLC was 9900.01. Then after optimizing, the optimized values of the components are resistance equals to 110 ohms, L equals to 1, C equals 0.001. The optimized impedance for those values was 110. Here we can observe that the resistance was increased than to the previous original value. So we can say that for optimization we can get the lower we not only get lower values but we also get higher values for not to get the final optimized value. Next, why Newton's method is preferred for solving this problem? Compared to other optimization methods such as gradient descent or evolutionary algorithms, Newton's method converges to the solution much faster, especially when number of unknowns is large. Newton's method is often preferred for impedance optimization of an RLC circuit due to its speed and efficiency. Newton's method is second order method, which means that it takes into account the curvature of the object function being optimized. Benefits of optimized impedance in an RLC circuit. Stability. The impedance of an RC circuit affects the stability of the circuit. When the impedance is optimized, the circuit is less likely to oscillate or become unstable. Efficiency. When the impedance of an RC circuit is optimized, the circuit is more efficient. This is because the power loss due to impedance mismatch is minimized. The applications of optimized impedance. RC circuit first power electronics. The first application is power electronics. RC circuits having optimized impedance are commonly used in power electronics to filter the unwanted noise and harmonics. In audio systems, RC circuits having optimized impedance are used in audio systems to control the frequency response and filter out unwanted noises. Medical devices. RC circuits having optimized impedance are used in many medical devices such as pacemakers and defibrillators. These are the differences I used in order to get familiar with Newton's method and get familiar with C++ coding. Now we'll see the running of the code in an online compiler. As you can see, it is the complete code. Now I'll run it. As you can see, for the given initial values, the initial impedance was 9900. Next, after running the method, we'll get the final optimized values of the components of the circuit. The final optimized values are R equals 110 ohms, L equals 1, and C equals 0.001. The optimized impedance is 110. That's it. Thank you.